morning, everyone. Can you hear me?
Yep.
Okay. Thank you. So today is October 15th. Again, this is SIG storage volume snapshot meeting, weekly meeting. And today we have a few items we want to discuss. So let's start from topology, like we discussed the last time. And so we have a PR for adding topology to the CSI volume snapshot. So basically, it's very similar to volume topology. And last time, I think we have a little bit issue related to comments for replication, because in the comments, we mentioned a volume should be accessible from two zones. And here we mention, okay, for example, specified volume is accessible from two zones, okay, synchronously replicated. And it seems require a storage provider so that if a volume is accessible from two zones, that means the volume should be replicated in those two zones. But we are thinking it should not such a requirement. We should specify here. So it doesn't matter how a volume is accessed, as long as it can be accessed by two zones, that's fine. It doesn't mean it must be replicated in those two zones. So so that's why I think here we kind of add a little bit explanation. This requirement may be satisfied by replication. We cannot assume it must replicate. But it's still, this is kind of not very clear. I think maybe we should remove synchronously replicate at all.
I think this is fine. Rewording it this way and making it explicit that replication is not required. I think that's okay.
Okay. But when we say create volume requires that specified volume to be accessible from two zones, aka synchronously replicated, what does it mean here? So
I would agree that synchronously replicated is orthogonal to the access requirements. And so it's not an AKA.
Yeah, so we should reword that to remove the synchronously replicated part and leave the while accessibility requirements may be satisfied by replication, blah, blah, blah.
That makes sense to me.
Okay.
The word synchronous is also superfluous, so getting rid of that helps.
Okay, sure. So if we remove this, since this is related to both volume and snapshot, then I think if we get agreement, then we can change for both volume and snapshot. Any other issues related to topology? I think that's the only comments we got so far related to topology, yeah. Okay, if not, we will make the change and then see whether we can be able to merge it soon, and also see whether anyone has other comments related to topology. Next item, so we mentioned we want to add deletion policy similar to volume, like PVC. So based on the workflow from volume, the PVC, right, we add deletion policy for snapshot 2. So one thing is, deletion policy is something only system mean we are thinking should specify. So only you can specify deletion policy in volume snapshot class. Right now, so we call it deletion policy. In PVC, they call it, I think, reclaim policy or retention policy. So we have only two options. One is retain, and the other is delete. So by default, if we don't specify any deletion policy, that will be delete. That means if a user delete a volume snapshot, then the corresponding volume snapshot content and also the underlying volume snapshot will be deleted. But if your deletion policy is retain, if a user delete a volume snapshot, the associate volume snapshot content and also the physical snapshots in storage will not be deleted. Only the volume snapshot API object will be deleted. And this is system mean can change through the volume snapshot class. User cannot directly change deletion policy. Any questions for this deletion policy?
Yeah, that's sort of a binary decision, but in like Swordfish, there's a time to live requirement that you might want to consider.
You mean want to consider what?
Instead of saying that the replica is deleted when it's not used directly, you give it a lifetime, that a minimum lifetime that says after that lifetime it can be deleted.
Oh.
Well, I mean, if someone wants to manage their Kubernetes snapshot deletion, or the snapshot deletion through Kubernetes, they would implement that time to live on top of these APIs, and then they would expect deletion to actually delete it. If someone wants to manage it underneath Kubernetes, then Kubernetes shouldn't be touching this stuff.
Okay.
I see the use case, but yeah, it's kind of.
Yeah, I think these two options are enough flexibility that people can get done what they need to do. There will always be people doing funny things outside of our knowledge.
Okay. So, but keeping in mind, this is through volume snapshot class, so only system mean can change it. Because volume snapshot class is used when creating snapshot, right? And if the deletion policy is defined, let's say retain or delete, then when the snapshot is created, the deletion policy will kind of put in the snapshot content API object. And depending on how you specify in the class, right, it will follow that either retain or delete. And user cannot change it afterwards. Only system mean might be able to change it. So it's fine, like.
Yeah, it seems fine.
Okay. So next is for deletion finalizer. Basically, it's to protect either volume snapshot or volume being deleted while it is being used. And we do have like a small document explain some of the protection we are trying to implement. So first one is volume snapshot content. We want to prevent you delete the volume snapshot content directly while it is still bound to a volume snapshot. And this is done by a snapshot controller. So we will add finalizer, right? When a volume snapshot is created. And we also check if the deletion timestamp is already set for this content, then we don't need to add finalizer anymore, since that indicates this content will be deleted. So either the controller can add the finalizer, or we could have admission controller to add finalizer. Then we will also check whether we should delete finalizer. When user, let's say, want to delete, right? The deletion timestamp will be added to the volume snapshot content. And at this moment, the controller will further checking volume snapshot content is currently being used. That means if it is currently bound to a snapshot, we cannot remove the finalizer. So finalizer will prevent you delete the content right now. Only if currently the content is not being used, or in another word, it's not bounded to any volume snapshot, then the finalizer can be removed and the content can be deleted. This is the protection for volume snapshot content. And we also have a finalizer for volume snapshot. So because when you're trying to delete volume snapshot, that's possible. Currently, this volume snapshot is used by creating a volume, right? Since we can provision a volume from a snapshot. So that's the goal for protecting the volume snapshot. So we'll add the finalizer to volume snapshot too. And when you want to delete volume snapshot, it will check, okay, whether this volume snapshot is currently being used by any volume. So the controller has to go through the list of PVCs and also check whether those PVC has a data source that match this volume snapshot. And only if the PVC already bound successfully, that means the volume is created successfully, so you don't need snapshot at all. If the phase is still pending, right, then we cannot remove the finalizer. Any questions so far for finalizer for volume snapshot and content?
I have a quick question. Can we delete a PVC if there is a volume snapshot created from it?
Yes. So our assumption is PVC, the volume life cycle, is independent of a snapshot life cycle. I know there are some storage that kind of have dependency, so for snapshot and their volume. But that will be determined by the volume plugin. So if you're trying to delete, let's say, a volume, well, it has some snapshot associated with it, and the plugin does not allow it. The plugin will return like an arrow when you try to delete the volume.
Okay.
The CSI volume plugin should return arrow. Then the Kubernetes CSS will kind of report this arrow up to the API, so user know why it cannot be deleted. But we don't provide like protection at our layer for that, because different volume plugin have very different, right? Some are independent, some are like have this dependency between volume and snapshots. So we cannot make assumptions. Yeah.
Sorry, what about protection during the brief time while the snapshot is getting created? So after you've created a new snapshot and while it's still being copied or whatever?
That's actually the next finalizer. That's the next one.
Right. This is the finalizer we put on PVC. So because we create snapshot, right, through a volume, we want to prevent you delete the volume while this snapshot is still being created. So we still plan to do this through snapshot controller. And when to add finalizer. So when there is a snapshot request come in, right, we can add finalizer to its associated PVC if there's no finalizer before added before. But there is to remove finalizer on this PVC a little bit trickier. So we are saying, okay, after you're done your create snapshot, the snapshot is already cut. We don't need the volume exist anymore. So we can remove finalizer at that moment. But we don't know actually whether there are other snapshots are being created by this volume at that moment. So we are thinking to use kind of called a count annotation. So we can check whether currently there are any snapshots being created or not. So the idea is, so when a snapshot request come in, we can like increase this snapshot in creation count number. And after the snapshot is cut, so remember when snapshot is cut, we will put the creation time into the API object. So we know when the snapshot is cut. It's not necessary snapshot is ready. So as long as it's cut, so we can decrease this count number. And the controller will check whether the count number, this count is equal to 0 or larger than 0, then decide whether we can remove the finalizer or not. And we are thinking also it might be useful, we can have also a snapshot, a ready snapshot count. So to indicate how many snapshots is created and already ready for this particular PVC. So any questions for this overall idea for remove finalizer using this snapshot in creation count?
This may be a dumb question because it's more of a general question, but what prevents races on incrementing or decrementing the count in Kubernetes? Is there a way to do a transaction that will prevent multiple increments from overwriting each other?
So normally when you update an object, right, it will return like a version. So if when you update, during this time there is another update, and we can check by through version and know, and it will fail to update, and you need to update again.
I see. Okay, that makes sense.
Yeah.
Jing, I have a question.
Yeah, sure.
So you mentioned admission plugins multiple times on this page. Is this same as admission controller that is part of the API server, or is it a separate plugin dedicated for snapshots?
So we'll have dedicated admission plugin for snapshot. No, it's not kind of, it's part of, it will be added as part of snapshot controller. So we already have a PR to add an admission controller, but it's kind of integrated into the snapshot controller. So as long as you, let's say, deploy your snapshot controller and set up the service for admission, it is a webhook, right? So as long as you set it up, then it will be like part of the snapshot controller.
That makes sense.
Yeah.
Thanks.
So there will be some kind of tricky thing we have to make sure, because let's say a create snapshot call may be called multiple times. If like the first one takes very long, so we should prevent you to like keep adding the count for the same snapshot. something related to that. So we will take care of that when implementing this. So all this finalizer, right? We cannot have like 100% guarantee. So there still might be some kind of risk condition, because when you check, right? When you check, okay, it is okay to remove finalizer, but before you remove it, the condition changed. And but it should be rare. So basically, we cannot have a atomic like operation by checking and then remove finalizer. So after you check, there's something might be like another event happened, and it's no longer true, but we still remove finalizer. I think this is the way for PVC too. So we don't have like 100% guarantee, but we should have a protection for most of the cases. Any questions for finalizer protection? So we have basically 3 finalizers, one for content, one for snapshot, and one for PVC, to prevent different scenarios. Okay, so far it seems it's fine. So we'll go ahead. We already have this working in progress passing. So we'll update it when it's ready. And for this count thing, currently we propose 2 counts. Any other like suggestions? One means how many snapshot is currently being created. That is in creation count. The other we call ready snapshot count. That means how many snapshots is ready for this PVC. Okay, good. So we can move on to next topic, which is related to consistent group. So Jing also have a document for this. So Jing, you want to give a introduction, like the idea of this group, volume group and the snapshot group?
Yeah, sure. So I think when in previous meetings there was some request to provide consistency group support. So basically, this idea is coming from Cinder. We implemented this one in Cinder. So we actually don't call it consistency group here because we want to make it more generic. So it's a volume group instead, and then actually that can support storage systems that can provide a consistent group snapshot, and also those that do not provide the consistency, and then they can still use this grouping concept. So this grouping concept can allow the volumes to be grouped together and then to be managed together. So there are mainly two API objects. One is called volume group, and the other one is called group snapshot. So the volume group will have a volume group spec and a volume group status. And in the spec, so we will have this data source. This is only when you try to create a volume group from a group snapshot. So you need this source that'll give you the ID of the group snapshot. But if you just to create a brand new volume group, then this you don't need this source. And we have a Boolean called a consistent group snapshot. So that can be true or false. By default is false. And name. And then we have this list, the list of persistent volume claims. So here you can define several PVCs that you want to be included in this group. And then the next one is the status. So here we have a creation time, group creation time. And then this Boolean, whether the group is finished creating or not. So this PVC list, it can either be empty or it can be a list of PVCs that has definitions. If it's empty, of course, you just create empty group, and after that, we can add PVCs to it. But if it's you already have a list of PVCs, then the PVCs will be created and bound after all of them has been bound. Then we can change the group status to ready. And this the arrow. Not sure if we can use this existing volume, the volume arrow API object, or if we need a new one, but we just use the existing one for now. So if some error happens, if you create a group of volumes, let's say if you have 5 in the list and you created 3 successfully, but a 4th one failed, and in that case, so that's a failure. So should return failure for the entire group. And so this is the same as all the other like create volume operation, create snapshot operations, right? This one also needs to be idempotent. So which means if the driver creates a volume group, if let's say if 3 was successful and then the next one failed, if the CEO, if Kubernetes makes the same call again, driver needs to make sure that it doesn't create, let's say it doesn't create 10, it should just still be 5, and then needs to handle the failure cases. So either, so at the end, if the request is to have this 5 PVCs, then at the end, it should just be 5 created to support idempotency. So
I have 2 questions.
Yeah.
Is the theory that the PVCs are defined externally as PVCs and this is just a list of their names, or the PVC definition is actually inside this object?
So yeah, it actually will be inside. So it's similar to how you do, let's say, the stateful set, where you have those PVC definitions inside.
Uh-huh.
Right.
So it's really a template object.
Right, yeah. So it should be, so it should be a template, yeah, not
well,
yeah. So template is also actually a.
I think we are thinking we should support both. Let's say if you create an empty one first, but then you add a PVC list later, right? So
yeah.
You can have,
so the reason it matters is because when it comes to the implementation of volume groups and consistent snapshots and stuff, a lot of the time the group itself is not particularly mutable. Like you can't add things to the group that weren't originally in the group.
Well,
on the implementation side. I mean, I realize in Kubernetes we can find whatever we want, but I'm just saying, like, if you define it to be that the group is mutable, that puts a really heavy burden on implementations to be flexible enough to take something that is not in the group and then put it in the group, because that could involve moving data.
Yeah. So it's really when you take a snapshot, then when you take a group snapshot at that time, that's when you can really support the consistency or not, right? When you're just creating a group of volumes at this time, we're not talking about a consistent group snapshot, right? So this is similar to what we did in Cinder. So you can actually add a volume to the group. You can remove a volume from the group. So
you mean I can remove a volume from the group, but then still use that volume as its own volume?
Yeah, but there will be, we'll need to, in the controller, we need to make sure that if it's part of the group, then you can't really just say delete that one group, and with it'll be error checks, right? If it has a group ID in that volume, in that PVC, then you can't just delete it. You can remove it, but you cannot really just delete it. When you delete it, you have to delete the whole group. So there will be some error changes there. So in the controller, we need to make sure that you don't just go delete a volume without knowing that it's actually in this group.
Okay, I guess that I just wanted to point out that this will ultimately set a very high bar for implementations to support consistent group snapshots.
Right. Yeah. So that's the reason we want to discuss, right? So we.
I guess the question is whether Kubernetes or previously Sender, they enforce consistency or atomicity across all the volumes, or is it the job of the plugins to enforce consistency? Because based on whatever approach we take,
right. It's actually, so I'll just talk about in Sender. That's the way we implemented this one. It's the plugin. It's the responsibility of the plugin, because not all the storage systems can support this type of consistency. But right now we're talking about this consistency group at the storage system level, right? So the plugin, only if the plugin can support this, then it can do this. Otherwise, it just say consistency is force.
So that
Yeah.
Well, the reason the main complication is that, for example, let's say somebody is using 10 storage backends for NFS or SIG. They don't necessarily know whether all these volumes are coming from the same backend, and they cannot rely on the capabilities of the backend to have consistency. They just specify their PVC.
You're saying that they have they want to create like group with different volumes are from different backend. Is that what you're trying to say?
well,
I'm saying, like, users would not necessarily know where their volumes are coming from.
Right. So that's why we have yeah. So this one doesn't have a. I wonder if actually should have the like a class like group. We actually talked about this one. So in Sender, for example, we do have a group type, right? So that the admin need to set that ahead of time.
yeah, I was going to point out that there's nothing here that enforces that you even use the same storage class.
Right. So basically, and then I was thinking in Sender, the only thing that we added in the group type is whether it's consistent or not. So that's why we, Jing and I, we actually discussed about that. So that's why we actually kind of moved it out. But maybe it makes sense to still have a type so that user knows, okay, there are different types. They support different functionalities.
But even that's not sufficient. Even if it's the same storage class, they can the volumes can still come from different backends, and the plugin cannot necessarily enforce consistency across them.
No, the type.
I want to actually
the type
tag on.
itself. But
Sorry,
the type itself will say whether it's supported or not, right? The type in the type it will define whether it's supported or not, and then.
Well, but here, I think what Ardalan is getting at is you could define a group that has a consistent type true, and then you can have two different PVCs that are on totally different pieces of storage, and you could put them both in the group. Now, Kubernetes will not stop you from doing that, but now the plugin has no way to actually.
I think in this case we was because this is the same as the other. When you create snapshot, when you create volume, you have this. The provisioner, or in the class you have that specified, right? So here is something that we need that as well, right? So you need to specify what is your provisioner, so okay, this plugin.
Well, but having the same provisioner isn't enough most of the time, because due to limitations of.
Well, that's the driver needs to make sure, right? If it can support or not.
Right, but that making sure could involve like moving the data as part of putting something into the group. Like the act of adding somebody to the group might mean that the back end, in order to make the guarantee that it can take a consistent snapshot, it may have to lift up the data from one place and put it in another place, which could be an enormous copy operation just to add something to a group. And you can do it, but it's not just like flipping a switch.
Right. So I'm thinking we can, let's say, add a volume to a group, but although the user requests this, but it might fail, then we need to have a way to show, okay, you cannot do this. So even
and more importantly, if I want to have like 10 my volumes in a group and I want to be able to take a consistent snapshot of them, there has to be a way to upfront tell the system that please put all 10 of these things in the same place so that they can be consistently snapshotted.
So I think, so maybe I'm incorrect, but I thought the storage class, with the exception of, something like Trident that does another abstraction of multiple backends behind it, and there's other cases that does that might do that as well. But that should work, and then it should be up to the plugin to determine the scheduling issues from there, shouldn't it? I mean,
yeah, I mean, the plugin is capable of addressing the issue. It's just adding things or removing things from groups could involve moving data around, and I don't know, that's not an instantaneous operation.
For a plugin that has multiple backends, yeah, that's true. But
doesn't Cinder support multiple backends? I thought Cinder also supports multiple backends.
But it's different because in Cinder, when you specify the consistency group, you're specifying against a driver. So it's all going to the same driver, which is the equivalent of a storage class.
But in this design, you can create the volume first and then add it to the consistency group later. And Cinder would have no way of enforcing that it went to the right place.
Okay, so let's not. I'm not sure what we're talking about Cinder here.
So I think your concern is more about whether we allow a volume to be added or not, right?
Right. When you make the group itself mutable, then the act of putting things in the group and taking things out of the group has a meaning, has a semantic meaning as far as where the data is supposed to be.
I agree it's tricky because I know that we have some, we did run into some bugs in Cinder, trying to add, you need to make sure that it's from the same pool, things like that. The scheduler actually got involved.
Right.
You need to add some special checks there. Yeah, so definitely it can be tricky.
So does the group have a storage class of its own?
So this is something that we are discussing, right? So right now, in this file, right now, we don't have, because Jing and I discussed
so
about it.
Let me just say out loud. If the group has a storage class, then you can check the class of the individual volumes against that class as an criteria. Or similarly, if I'm going to create a group with a class and I specify how many volumes, I know what to create. So I think you need to add that concept.
Right. Yeah, definitely we'll need to add some checks to make sure that you can add that volume to that group. Definitely. It's just, it's definitely error prone that I completely agree.
So I agree with the concerns about whether this should be mutable or not mutable. But before we discuss that, I wanted to take a step back and put on my API reviewer hat and question, do we need another API object? What is the end purpose of doing something like this? And I understand the idea that we want to be able to snapshot multiple volumes and end up with a consistent snapshot across all of them. But the way I was imagining this would work was through the grouping that we already have for volumes, which is the workload, the pod. Yeah. So when you create a pod, you specify the volumes that you're concerned about for that particular application. And in general, when you want to take snapshots of multiple volumes, the natural grouping is the consumer of those volumes. So if we already have the pod as a natural grouping, maybe having some way to trigger a snapshot against a pod object to say, please take a consistent snapshot of all the volumes that are available to this particular pod, that seems more natural to me. And it can also take advantage of the consistency or the lifecycle hooks that we could inject into the pod object, right? So for QSing and things like that. And what we can, if we have those, we could potentially end up building a system that would work across more storage systems, not just storage systems that enforce consistency.
And Saad, if you have quiescing at the pod level, you don't need consistent snapshots because in theory there's no I/O happening. You could just take individual snapshots while everything's quiesced and have something that ends up consistent.
Right, and if there's an application that doesn't consume the QSing hook for some reason, and there's an underlying storage system that does support consistency groups, potentially you could take advantage of that as well. I think it opens up a lot more opportunities.
But you're going to have the same problem where you can attach lots of PVCs to a pod that don't have the same storage class, aren't in the same place.
Right.
For a variety of reasons, it may be impossible to actually take that consistent snapshot.
Right. The biggest concern I had was the mutability aspect. I don't like that. The nice thing is that once a pod is created, it is essentially immutable in terms of the number of volumes that it has. So that's good. But your concern is right. You could have a pod that references 3 different volumes from 3 different backends. I think that would be okay. We need to think about how to handle that. One way is that we, let Kubernetes handle the snapshotting and QSing of the workload, and then it just triggers 3, snapshots against 3 backends at the same time. Or if it recognizes that all 3 of them belong to the same, or 2 out of the 3 belong to the same storage system, it issues some, group snapshot call to say, please create a snapshot of volume A and volume B. And then
I think what's really needed is a hint to the thing that's scheduling PVCs to say, like, I want to create 3 PVCs and I want them to end up in the same place. And so I need a way to basically, when I create those 3 PVCs, add a little bit of metadata that says, go, I don't care where it is as long as all 3 are in the same place. And then if I use those 3 PVCs in a pod, and I can be guaranteed that I will have the ability to take a consistent snapshot because they will all 3 have gone to the same place. In a sense.
Saadi's suggestion is different. He's saying the PVCs don't have to end up on the same place.
Right.
The way,
if you want to be able to do it at a higher level, but I'm saying, like, if you want to rely on the storage system to provide like extra consistency guarantees, you need a way to, before you create the PVCs, tell the storage system, I want these to be in the same place.
So I think that I really like the approach that Saad mentioned, right? Because that makes the most logical sense for the use case, and also makes the most easy workflow and use case for the end user. What I'd like to see would be awesome is address that first, and then figure out if you want to do some special scheduling enhancements for volumes to a back end for your special use case, Ben. Then we should look at that as a separate thing.
One thing I'm wondering is a pod, right? You can have many different kinds of volumes. So like some are persistent, some are like ephemeral, and so which like volumes should be part of the group, and it's not like easy way to specify, right? There may be 10 volumes for that pod, but 2 of them belong to one group, the other 2 belong to a second group. I'm not sure whether it's a use case for that, or
wouldn't you
say you
do
take
all
snapshots?
PVCs associated with that pod?
Hmm?
Wouldn't you just do all PVCs associated with that pod?
So you mean, but I mean, like, you might have different kinds of volumes, right?
He's not saying all the volumes, he's saying just the persistent volumes.
Yeah.
Ignore the non-persistent volumes.
So then you assume all the persistent volume should belong to the same group?
No. Well, the group is the pod, right? So the pod is the group.
How about you have maybe 2 pods should belong to the same group? How you specify that? Or
I'm not sure what that context would be, but what you could do then is just issue the snapshot on both of them. The thing is the only things, unless you get into multi-attach, the only things actually writing data to those PVCs would be in the pod in most cases, right? I guess it's not always true.
So I'm the use case I'm thinking kind of a stateful set, right? You have 3 pods, and 3 pods have their volumes, and then those 3 volumes might be a good for consensus group if you are trying to have, let's say, replicas for those 3 parts.
So in that case, what I imagine is basically building an equivalent operation for these different classes of deployment objects that we have. So initially we start with some mechanism that will allow us to create a snapshot of a pod. I don't know, call it, pod snapshot. Once we have that primitive ironed out, we have a ability to take a consistent snapshot of all the persistent volumes for a given pod. Then we can use that to leverage it to build higher level functionality. Just like stateful sets builds on top of pods, replica sets builds on top of pods. You could introduce higher level primitives that say, snapshot stateful set, and it can do the custom logic that is required to handle that higher level snapshotting, but then use the underlying primitive that we exposed, which was, pod snapshot.
Sad. So Jing and I talked about the stateful set a little bit. So let's say if you have the replica number is 3, and then in your template you have, let's say, 5 volumes, right, in your templates. So when we talk about this consistent group thing, does that mean we need to create 3 consistent groups? Each group will be associated with a pod or with one replica of the stateful set? Because we're not really, if there are multiple replicas, we're not putting them all together in the same group, right?
So I think it would become an option at the stateful set snapshot controller level. So for the stateful set snapshot, you have one of 2 options. One is that you get consistency per shard, or you get consistency across all the shards. And if you choose to do consistency per shard, then essentially what we do is just go out and create a bunch of pod snapshot objects, and the pod snapshot controller handles that. If they want consistency across all the shards, meaning all the volumes across all the instances, that's a little bit more challenging, but you can imagine doing something similar to what we did with the pod snapshot as an extra option at that level.
Shouldn't we have a use case in mind before we try to imagine why we want to do these things?
Going from the bottom up. So, we introduced the very basic primitive of creating a snapshot against a single volume. I think the natural next extension of that is let's focus on the pod. Once we have something at the pod level, we can start going up the stack and see what additional things we need to add in addition to the primitives that we already have.
Sure. So I think that's also a good kind of way to design it. But one thing I want to make sure is if we say in the pod level, right, then when you create volume, we need to kind of already indicate, okay, this volume should be in a group like Ben mentioned, right? So we need to say, okay, these volumes should be created, belong to this group, and the driver might do something, place them into like the same place, or right now we don't have that really way
but I mean,
say when you create a pod and you specify volume, and we don't have a way to specify, okay, those volumes.
So I see that as an optimization. The way I see it is the pod is the natural grouping. The easy first implementation of this should be the pod snapshot controller looks at all the PVCs and triggers, first it calls the QSing hook against the application to make sure it pauses the application. Then it calls snapshot against each of the volumes. And once that's completed, QSs the workload. If we want to get fancier and say, okay, 2 out of these 3 volumes are of the same type, and the storage system should be able to do fancy things to make sure there's consistency between them, we could leave that logic to that pod snapshotter to figure out when it's issuing those snapshot calls, as long as it has some way to tell the storage system, instead of taking a snapshot of one volume, I want to take a snapshot of a list of volumes, then the underlying storage system can handle that however it wants to.
Oh, okay, but my question is, so in order to take a consistent like group of snapshots, we have to first have those volumes like created or put in the, we call it consistent group, as that's how I understand singular. So you need to have this group first, a volume group first.
What is a volume group?
Kubernetes doesn't necessarily need to know what that is. You could do
Exactly.
that out of band.
So I think if we do the support snapshot, then it's going to be so we'll achieve like application level consistency, but it doesn't really guarantee this storage system level consistency, because so the snapshots will be taken one at a time, right? So I think we will not consider that as a first step. I think that's
yeah, I think application level consistency should be the higher level priority, and whatever mechanism you come up with triggering this, you could have additional options on it. So for example, if we model it similar to the way that we modeled the volume snapshot, we have something like a pod snapshot, and then you could have options that say, I also want storage level consistency. By default, that option is off. So you only get application level consistency. Kubernetes can handle that. If you check this option.
Hold on. Application level consistency is better than storage level consistency. Yeah. If you have application level consistency, you're done.
Yeah.
Storage level consistency is only interesting when you don't have application level consistency.
Yeah. But if for some
the application
reason
is biased, if the application is biased and you have distributed snapshots, each one of them together, they're going to be consistent because there's not going to be any IO in flight.
Yep.
Okay. Then I think for
once
that
the application is paused, you don't have to worry about storage level consistency, I think.
Okay. Yeah. For that purpose, application level consistency, I think we actually need a different direction. We need to first to see how we class application, because we don't have that hook yet. So
that's probably a better place to spend effort.
Right. So that's a kind of a separate feature we want to go. So here is more or less for storage consistency snapshot, because some storage provider like Singular have their consistent group. They call it a volume group, I think, or group volume, and also a snapshot group. So that's for that feature. So for application consistency, so we'll have a kind of a different discussion. Yeah, we need to see how to add a hook for class application at pod level. Yeah. So it's
between
like,
storage level consistency and pod level consistency or application level consistency, I think application consistency should be the higher priority here.
Okay. Then so we can have a separate design related to like application level consistency at pod, right? So probably next time we can have some idea about that and discuss that. So for this time,
sounds good.
Yeah, we can leave it for now. Then we can kind of go back to this, how we will address this after that discussion. So it's almost the time, and any other comments or questions about what we have discussed so far? Right now, yeah, we encourage everyone start using our alpha feature snapshot, and then let us know your experience and what's. Okay. So that's for today. If no other questions or comments, so let's see you next time.
Thank you. Bye.
Thank you.
Nice. Bye.